Okay. Creativity is one of the most important things we have and something everyone feels for. So let's imagine that you've made this amazing game. The graphics are shiny, everything runs smoothly on your big PC, and life is good. You think that you might have the next Angry Birds on your hands, and you just need to release it. You start building out on your semi-new phone, and nope. The frame rate tanks, and you can't run it. You realize that you can't even run it on your friend's MacBook. All this work for nothing? Optimization is a very important part of game making, and today I will hopefully guide you through some of the dark areas of light baking. My name is Jennifer Nordwall, and today I will hopefully teach you how to bake at the speed of light. So, I did a similar talk roughly 2 years ago. It was just after starting Unity, so it was still a bit new to me. So this talk will basically have the same setup as before, but since 2 years has passed, hopefully we have developed stuff, so I will talk about that. Some new features, how to bake faster. So first I will talk about the basics. This section will no longer include real-time GI with Enlighten, since it is being deprecated in 19.3. And then I will talk about some of the common issues and new tooling that we have for that. And then I will talk about some of the new features that we have added in the 19 cycle. So, the basics. How many in here are familiar with what baking light means? Okay, so a few. So, realistic light is extremely expensive to calculate, since it's just so much information. To achieve convincing results, we need to calculate the complex behavior of light rays as they bounce around the world. So many rays that bounce around contribute to indirect light shadows. So what my team essentially is doing is come up with ways of cheating this, so we can make light look nice, but at the fraction of the computer power. So for example, instead of calculating how shadows look in every frame, we do this in a pre-compute pass, basically baking. This results in a texture or a light map, which we then dress all the objects in to make it appear that they have shadows in indirect light. The upside is that it's fast. The downside is that it can take long to bake, and you can't really move these static objects around. So what about path tracing? The progressive light mapper, compared to Enlighten, our previous baking backend, is an actual path tracer. This means that it shoots out rays that then calculate how they bounce around, and that will result in indirect light and shadows. Path tracing and ray tracing is very often used in software such as Maya and Blender, where the light is calculated by shooting out rays from the camera's point of view. So this technique works great when rendering static images with a fixed camera, but not when trying to bake light for a scene where you want to move around. So instead, imagine this. So every pixel of the surface will look out into the world and try to calculate how light and shadows will affect it. This way, we get a world where you can move around in. So great, let's get started. Before you do anything else, you want to decide which objects are standing still and can be baked. It's called static objects. For you who haven't used the 19.2 version yet, a lot has changed here. We have basically split up the old Lightmap static flag, as you can see here. So it used to be Lightmap static up there or down here, but now we have split it up so you can decide how you want the object to receive its GI and how it wants to contribute to GI. So for it to be baked in light maps, this is kind of the setup you want to have. So you want it to contribute to GI, but you also want it to receive it using light maps. Then you need to go into your lighting settings window and turn on Bake Global Illumination. Before, there used to be real-time GI, but since it's being deprecated in 19.3, I'm not going to even mention it. And then you need to make sure that you have at least one light that is being baked. So this scene is now ready to get baked. So, settings. first of all, I need to explain what this indirect or global illumination that I'm talking about. So if you look at this image to the left, it's a very dull, dead image where we only have direct light. So the light comes in once, and it basically hits the surface, and then it's over with. It's very, very fast to compute, and this is what we used to have in games back in the 90s. And it doesn't look very realistic, because this is not how light behaves. So instead, what we want is the global illumination. So in the image to the right, we have both indirect light and direct light. So you can see the indirect light bouncing around and causing it the redness onto the sphere from the wall. So indirect light and direct light is something I will bring up a lot in this talk, so hopefully it's clear as gold. And this brings us to the first setting, which is called lighting mode, but also referred to as mixed mode. It was added a few years ago, and it was the first thing I was part of as working at Unity, and it resolves a few very important problems. So if we look at the setup, and if we have only real-time lights or if we have baked lights, we start seeing these gaps. So for example, if you're only using real-time lighting, you will not get any indirect light, neither on your static objects that doesn't move or your dynamic objects. But if you want to use baked lighting, you're not going to get any indirect light or direct light on any of your dynamic objects. So anything that moves around, we can't really bake, because that would not make sense, because they need to be able to move, and textures are static. So how does this look in theory? I'm going to bring up this old Goldie. And the walls and the floor and the sphere to the left is marked as lightmap static or contribute to GI now. And the light is baked. And as you can see, it gets this nice direct light, and it also gets the bounce. Oh God, it's so bright in here, you can't really see. But yeah, it gets some redness from the walls onto the sphere, and it also gets the shadow. So, it's all good. Then you have this little blue sphere here, which is marked as dynamic, because it needs to be able to move around. Imagine this being your game, and this is the hero, and it just looks like a flat circle, basically, because it's not getting shadow, indirect light, or any direct light. So we want to be able to fix this. And this is where the mixed lighting comes in. So first of all, you need to select that on your light. And then you need to go into the jungle of these three modes. So you have baked indirect light, shadow mask, and subtractive. And as you can see, the indirect light is always baked. But then you have, it's basically a matter of weighing performance and quality. So baked indirect is the heaviest. Everything is real time except indirect light. Whereas the subtractive is very good suited for mobile phones, for example, where if you have one real-time shadow caster, which is really good if you have an open scene and you only have one directional light, most shadows will be generated from that anyway, so it's a good way of saving on performance. So if we go back to this table again, we can see that now we have a new column here with the mixed light. So the direct light is now basically covered. So depending on which mix mode you've selected, it's either real-time or baked. We still don't have any direct light though on the dynamic objects. And this is where light probes comes in. So these are these probes that you place out in your scene before you start baking. And we basically bake in the indirect light into these values in these probes. And then when the character moves within this cloud, it samples from the different probes and interpolates between them, just to calculate a rough value of what its indirect light should be. So if we go back to the table and we add the probes, we're basically covered on most cases. Of course, reality is a little bit more complex, but this should give you enough to get started. And then we come to the Lightmapper. So before you used to have a selection between Enlighten and Progressive, but since Enlighten is being deprecated, I suggest you to use Progressive. So this comes in two versions, the CPU and the GPU. So the CPU is using your normal processing unit, whereas the GPU is using your graphics card. So if it can be extremely powerful if you have a computer with a really, really good graphics card, but if you're using a 5-year-old MacBook, it will just fall back to the CPU. And for all the images that I've done in this talk, I've used the GPU Lightmapper because I basically couldn't wait 5 hours per image. So the next option is the prioritize view, which puts the progressive in progressive Lightmapper. And you've probably seen a lot of images of this where you basically move around in the scene when you're baking in the editor, and you bake what is in the viewport first, and then you bake everything else. So the bake will 100% complete, but you are able to iterate much faster on a specific problem area. And then we have samples and bounces. So first I want to describe how these work, and then I will go through the settings. So I made these nice drawings here. So this is the direct samples. And let's say you have 5 as a direct sample rate. So it basically shoots out 5 samples per pixel per light. So if you have a lot of light, it will be more expensive. And let's say you're using a lot of point lights. There's not really a need for a high sample count. But if you're using these really nice area lights and you have stuff that will cause shadows within the area lights, you might want to crank up the sample rate so you get this nice angle of this dark sphere that's occluding it. And then you have the indirect samples. And in this example here, I'm shooting out 3 indirect samples, and it has the bounce count of 2. So it basically shoots out in a random direction, hits the surface, go in another random direction, and once it has reached its bounce count, it will go back, tell the texel, hey, I met a blue texel and a red texel, and you should maybe be purple. So if we look at the different area or the different light types and what samples they use, so please know that all of them are being sampled by indirect light, but only the area lights, directional light, point light, and spotlights, and various HD render pipe shapes are being sampled directly with direct sample lights. And the skybox is now using environment sample. The emissive are only being sampled with indirect samples, basically because we don't know the shape of the emissive, so it's really hard to know. So what this means is that if you, for example, have a lot of noise coming from your skybox, I suggest that you crank up the environment samples before you start toying around with the indirect ones. And the same with area lights. If you have a noisy area light, you might want to crank up the direct samples. With emissives, go straight for the indirect. And one thing worth noticing is that before we used to have a fixed sample rate for light probes, which was 2048. So it was 2048 direct, indirect, and environment samples on the probes. But now we give you the option of using a multiplier of these samples. So a good value is maybe between 4 and 8. But if you get a lot of noise from your light probes, crank that up. So these images are baked without any filtering or denoising. It's just the pure samples. And I did this on my 3-year-old 1080. And I think, yeah, it was quite fast. And I think this one would have taken 5 or 6 hours on my CPU. It's also a very old CPU. But please know that here you can see how the baking time is very linear in comparison to the sample count. But the result, the further up you go, the less result you get. So it's basically exponential. So even if you go from 10,000 samples to 11,000 samples, there's a point where it's just not going to get much nicer. And this kind of brings us to our next topic, filtering. So a lot has happened here in 19.3, and we've added a few new options. So if you don't want to use auto and go straight to advanced, we have added these denoisers. So there's 3, and I'm going to talk about them more later. So let's talk about filtering. So, before we do anything with filtering, please make sure that your UVs, so basically the cuttings, how to layer out these flat light maps. So, because it's a 3D world and we're working in a 2D space, this is basically what it's going to look like. So if you go in on UV charts up in the drop-down, so here you can debug if you're getting weird hard edges or smooth the result where you shouldn't. That's just because the filtering just basically filters within this space and it doesn't know how to like go between the lines. So first of all, we have the Gaussian filtering. Very easy to use, very fast, and it's using a kernel size, so it doesn't respect any edges. So it basically just goes over everything and makes it a little bit more smooth. And in this example here, it's very not good because it looks like all the boxes are basically floating over ground because their shadows are meant to be square, and now they're round and nice, and it looks a little bit weird. Then we instead have a true, which is edge aware. So doing this by basically using the same image and filtering it in a few different sizes, and then it scales it up, and then it can tell if it's just a lot of noise or if it's an edge. Please be aware that this is currently not working with the GPU Lightmapper in 19.3, but it's something we're working on. So if we're using the scene from before, with no filtering on 1,000 samples, it looked like this. And with just turning on filtering and 1 minute more, it turns like this. So you don't need to crank it up and wait 5 hours with 1 million samples. Last but not least, don't forget to hit generate. And one thing here is that we basically turned off auto-generate by default, because it is something that you should do when you're iterating on something, not as a default. So once you have your bake done, untoggle auto-generate and hit generate so you get the lighting data asset, and then you will have less problems when doing multi-scene baking, for example, because having different scenes with different settings for the auto, it can get you in a lot of trouble. You have no idea how many bugs we get just because they used auto in one scene and non-auto in one scene. And this brings us to common issues. First of all, we have UVs and artifacts. And here we have a nice smiling sphere. So what are UVs? This is basically the coordinates that we want to use when applying the textures onto the 3D object. So, of course, we're going to have some issues when we're going from a 2D space to a 3D space, because it's not always perfect. And that's when we basically get artifacts. So one of the new toolings that we've added is a new UV overlap in the scene shaded view. And here we can clearly see why and like where the issues are. But how should we solve this? So if we go in under the lighting tab, so the last one we have baked light maps. Open the new preview window and go in under baked UV overlap. You can see here that the islands are just too close together. We recommend that you have at least 2 texels between them so you don't have any leakage between them. Because they don't want to have values that is meant for another island, basically. And in my previous talk, Bake It Till You Make It, I go through this a lot more, but since nothing has really changed, I'm just going to recommend like the pack-in margin here. So just make sure to increase this if you're allowing us to do your UVs until you have the two texel density. This is something that we are working on actively in the team, and we have new features coming in for 20.1 where it will be a lot more easy to do this, because we know it is a pain and we just haven't done enough here. This brings us to seam stitching. So this is basically a problem the same with these islands where they don't really know about each other in the baking process. So the values between the 2 islands can be a little bit off, and this basically looks like this ugly little seam. And you can see the cutting of the layouts. So if you go in on your mesh renderer and you hit stitch seams, you allow so you need to do this before you bake. So we're basically we're taking the values in the two different islands and we're making sure to interpolate so that the values are more similar so that this seam doesn't appear as much. Then we have textile invalidity. Oh God. So here we have a plane with no back face, and we have a lamp shining from behind, and this shadow on the floor just makes no sense. It's a very ugly artifact, and we're gonna have a look what is happening. So if you go in on textile validity, and now you can really see what is happening here. So this area, all these textiles are sampling a back face, and they don't really know how to interpret this information because it's basically marked as invalid. So they mark themselves as invalid, and then they rely on the neighboring green textiles to interpolate over and kind of resolve this. In most cases, this works, but in this case, we need to go in on the material and turn this little toggle on. So it doesn't get two faces, because that's just even more heavy, but we wanted to have a double-sided from a GI point of view, so that the baking backend can see the both sides. So it's fixed. So now you can see you get some of the red albedo bouncing on the ground. Everything is good. So why are we not just turning this on by default? If we have these two boxes here, the one to the right doesn't have double-sided GI on, and the one to the left does. None of them are floating above ground, but we have that as an artifact. So if we look a little bit closer on the left box, we can see that some of the textiles are a little bit inside of the box. And since we turned on double-sided GI, when it samples, some of the sampling goes within the box, and we have now told it, like, this is valid information, you have to use this. So it gets some dark textiles and some bright textiles from the outside, and then it tries to interpolate between them, and you get this ugly shadow that's not meant to be there. New features. First of all, we have added a few really cool denoisers. And for everyone, maybe they're still showcasing the open image denoiser from Intel down on the hub. This works on all platforms. Then we also have optics, which is from NVIDIA, and then we have Radeon Pro from AMD. So depending on which kind of hardware you're using, you can use the optics or Radeon Pro, but the open image denoiser should work on all platforms. So if we use this scene again, and we really cranked down the sample count, so now it's 20, 50, 50. So 20 direct samples, 50 indirect, 50 environment samples. If we just do normal filtering, it looks like, you know, it's been, I don't know, went through a burning, yeah. But with denoising, it takes 1.5 minutes more. It basically looks like the one we did that took 13 minutes with filtering 1,000 samples, but now we're just using 50 samples and the optics, open image denoiser and 3 minutes. And then we have this thing. This was introduced in 19.2. So we allow you to not having to do these hacks anymore. So you can basically decide if you want the object to contribute to GI and how it's going to receive it. So if you look at this table, we have the first one, which doesn't contribute to any GI. It's just a dynamic object, and it's using light probes. So this is what we always had. It's just a normal dynamic object. Then we have this option, which is not available. We're still discussing if we should implement it, but yeah. And then we have this option, which was the one we added. So you can decide that you want it to be seen by the light mapper, but you wanted to use light probes to light itself. And a lot of people might have heard of the little tricks scaling Lightmap 0 that a lot of people used, which basically just resulted in the object getting 1 pixel of albedo and emissive in terms of the light mapper. So they still showed up on the ground, for example, if it was a light post, but then it used light probes. But with this, it's just less hacky, and it allows you to maybe, if you have a big Italian flag on the wall, it can get like nice bounce on the ground, which is the correct color, just not 1 pixel. And then it doesn't need to use a light map to get its indirect light. So then you can use light probes. And we really recommend to use light probes a lot more because it speeds up the bake. And if you just have very tiny objects, for example, you don't need to put them in the light maps, just increase the bake time. So try and use probes a lot more. And then we have the last option, which is just basic old Lightmap static. So this brings us to another really exciting feature. We are trying to push people to use light probes more, but we realized that people are making bigger and bigger games with multi-scene editing, and you want to load in new scenes. And light probes couldn't really handle this. So if you had this example here, you had scene A and you had scene B, and both of them had a light probe group. It was only scene A's light probe group that was being sampled when you loaded in B additively. So if you baked them together, that was fine, but if you loaded it in one by one, the light probe group in scene B was just dead. So we have added this new API, which is called lightprobes.tetrahedralize, and there's an async version. Please use with care. This is not something that you snap your fingers and it's done. So if you're going to load in 100 scenes, load in your 100 scenes and then do this call as a last step. But it will make sure that all the probe groups are being merged and you can sample from all of them. Very nice. And this one isn't really new, but we have noticed that a lot of people don't know that it exists, and then they come to our evangelist and like, hey, like if there was a way of just seeing all my lights in one place, that would be super good. And we're like, yeah, but go into window rendering and lighting explorer, and there you have it. So you can basically batch change and see all the lights. In 20.1, I've also added so you can see lights that are also inactive. So even if they're not toggled on, they will show up here. So that's a cool feature. One new thing, though, is that if you're making your own SRP, or you're using HDRP or Universal Render Pipeline, this API is public. So you can basically, if you're adding a new light type or new properties to your lights, you can change this as much as you want. Add new tabs, new columns, custom objects. So yeah, you name it. And then we have this little thing. Oh my God. So it's basically, we have added this slider, so if you're using HDR light maps, yeah, now you can change the exposure on the light maps used in the scene view. This also existed on the preview window, so you can adjust it there, but it makes it easier to debug your light maps. A special thanks to my team, and Kieran Colnut and Thomas Friedel for the art, and thank you. So I've been asked for you guys to use the mics, but I don't know where the mics are. Where? Oh, okay. They're standing up there. Sorry, I can't see shit.
Hi.
Okay. Sorry, I was sailor.
Okay,
yeah, shoot.
So in the past, I've seen presentations where they basically recommended to lay out your light probes in complex word. Basically in pyramids.
In pyramids?
Rather than cubes, like double-sided pyramids, tetrahedrons.
Yeah.
So would you still recommend for that, for performance reasons, for example, or do you think grids are just as powerful?
It really depends on the scene, and I'm not a technical artist, so I don't use them on a daily basis. But I've never seen our technical artists putting them in a pyramid.
Okay.
So yeah, if
just go ahead with grids.
Yeah, like you saw that scene there. That's the guy in our team. He made that one, and it's just basically everywhere.
Okay.
Yeah.
Thank you.